Hey Year 10s, let's take up assessment 4 based on factorizing 3-term quadratics and factorizing 2-term quadratics, including dots. This first question could have been done in two different ways. You could have either factorized the quadratics in column A and matched them with the brackets in column B, or you could have expanded the brackets in column B and matched them with the quadratics in column A. I'm going to go this way and have a look at these factorized quadratics already and see which quadratics these relate to. This first one's very interesting to me because I notice that it's the same numbers but different signs, +3 and -3. That reminds me of a dots, difference of two squares, because the middle term is going to be the sum of these two values, and 3 minus 3 is 0. There is no middle term, there's only two terms, and the two terms are squared term. X times x makes x squared, and +3 times -3 makes -9, and again +3 plus -3 makes 0. So this is our first one. This next one is not a dots. I've got two different numbers here, and they're both negative. That's two negative numbers. I know they're going to multiply together to make a positive number. Right? They're going to multiply to make positive 10, and two negative numbers, they're going to add together to make a negative number. That's going to add to make -7. So here I could have factorized this one and thought, what numbers multiply to make 10 and add to make -7? They must be both negative, and they must be -5 and -2. -5 times -2 makes +10, and -5 minus 2 makes -7. Okay, next one. This isn't really a 3-term quadratic, it's just a 2-term quadratic. When I multiply this through, I'm going to get an x squared term, and I'm going to get an x term. I'm going to be missing my last term. It's a 2-term quadratic where both terms have x. I've got my x squared term and my x term. So I'm going to completely ignore this one for now. It's not that one either. It's got to be this one down here. Looking at those two terms, I can see I could divide them both by x, but more than just x, I could divide them also both by 5. So that's this one here. 5x times x makes 5x squared. 5x times -2 makes -10x. Next one, I've got +3 and -3 as my numbers here. I know those multiply to make a negative number. When the signs are different, the product is negative. And +3 minus 2, that adds to make 1. So I'm looking for a quadratic here where the last term is -6 and the middle term is 1x. This one right here. Multiplying that through just to show you, x times x would make the x squared. X times the -2 is -2x. 3 times the x is 3x, -2x and 3x makes 1x. And again, 3 times -2 makes it a -6. The last one here, it's got to be the last one I've got there, but let's just double check here. Numbers that multiply to make a +15 but add to make -8. They must have the same sign if they're going to multiply to make positive, and that sign must be negative in both cases if they're going to add to make a negative. So, yes, -3 times -5 makes +15, and -3 plus -5 makes -8. Next question, here's a little bit more challenging because you have to fill in the blanks and factorize for yourself without typing any extra spaces, commas, or punctuation, or it won't be read properly by the computer. So looking at this term here, or this expression, it's not even a quadratic. There's no x squared term. There's a hint about your answer here as well. There's no brackets for this first blank. It's just the common factor that goes out front. And in this case, the common factor is 2. If I divide this term by 2, I'll be left with x. If I divide this term by 2, I'll be left with 2. So inside the bracket, I've got x plus 2. This next expression is a quadratic. It's got an x squared term, a number term, and in the middle it's got a number and an x term. I want to find two numbers that multiply to make 4 and add to make 4. What two numbers multiply to make 4? Either 1 and 4 or 2 and 2. And add to make 4, 1 and 4 makes 5, so it must be the 2 and 2. It multiplies to make a positive, so both the signs are the same, and it adds to make a positive. Those two signs cannot both be negative, so it's +2 and +2. Okay, now this is the bonus part of the question, because if you know how to factorize both the numerator and the denominator, you should be looking for a way to simplify a fraction using the highest common factor. The highest common factor of the numerator and the denominator we've just worked out. Look at the factors. What factor have they got in common? they've got x plus 2 in common. I can divide both the top and the bottom by x plus 2, which is difficult when they're in this format, but we've already factorized them. If I were to divide this by x plus 2, I would just be left with a 2. If I were to divide this by x plus 2, I would just be left with one of these x plus 2's. So at the top I've got 2 and at the bottom I've got x plus 2. So that's why that's a bonus question, but really you've done all the hard work already up here. Again, another question like that where we're factorizing these expressions, and this time both of these expressions are quadratics. They both have x squared terms. In fact, they both have all three terms. So I'm going to start by setting up x in both brackets because x times x will make my x squared. And I'm thinking what numbers multiply to make 1 and add to make 2? It's 1 and 1. 1 plus 1 makes 2, and 1 times 1 makes 1. Okay, the next one, again, it's a three-term quadratic, starting with x squared. X times x will make the x squared. Now I'm thinking what numbers multiply to make positive 2 and add to make 3? Signs must be the same. Possible numbers that multiply to make 2 are 1 times 2 or negative 1 times negative 2, but they need to add to make positive 3. So they're not both going to be negatives. They're both going to be positives. That's plus 1 or plus 2. You can do it either way. You can either do x plus 1 and x plus 2, or x plus 2 and x plus 1. Either way. Now again with the bonus, I bet you could do the bonus now, even if you weren't able on the assessment. We're looking for the highest common factor. Looking at what we've done above, we've already factorized both of these quadratics, and I see a common factor. The common factor is x plus 1. If I divide both the top and bottom by x plus 1, this x plus 1's gone, and I'm just left with this on top, and this x plus 1's gone, I'm just left with this on the bottom. So my simplified fraction is x plus 1 over x plus 2. Okay, now recognizing what type of quadratic it is will help you when you need to factorize or solve it. What type of quadratic is this? We need to use a 4-letter word. Now let's keep the profanity to a minimum here that we use to describe these types of quadratics. They have x squared minus some number, x squared minus some number, 25x squared minus some number. These are all the same kind of quadratic, a two-term quadratic, and it's always something x squared minus some number. The minus makes me think of a difference, of two terms, and both of those terms are squared term. X squared is x squared, and 1 is the same thing as 1 squared. X squared is x squared, and 16 is the same thing as 4 squared. This is a squared term because this is the same as 5 times x times 5 times x, right? 25 is the same thing as 5 squared, x is the same thing as x squared, and so on. They're all squared terms with a minus between them. They are all differences of two squares, dots. Next, which of these quadratics is different from the rest? So again, identifying what type of quadratic it is. I see another dots here. I see another dots here. I'm seeing a lot of dots here. Are they all dots? Not that one, because that's got an X in it. And which of these quadratics are different from the rest? Well, that's definitely not a dots, but these are all two-term quadratics. Is that the one that's different? Are the rest of them dots? That may look like a dots, but watch out because there's an X here. So that's no way that I've done something multiplied by itself to make 100x. That's not a dots. That's not a dots either. However, I could factor out the 5, and that would leave me with x squared, and that divided by 5 is 4. So I'd have 5 on the outside, and then I'd have x squared minus 4. This is technically a dots, but more specifically, I'm missing the middle term here. Here I've got all the middle terms, and I'm missing the last terms. So this is the one that's different. Again, two of these expressions are not quadratics. So which two terms, there are two expressions now, don't fit? Now, a quadratic, remember, ax squared plus bx plus c should have three terms, although sometimes one of them is missing. They must have the x squared term. And this first expression here, 2x plus 4 minus x is trying to fool you. There is no x squared term there. That is not a quadratic. What other one's not a quadratic? Now this is in the wrong order, but it's got 3 terms. It's got an x term, an x squared term, and a number term, so that is a quadratic. That one's fine. This one here doesn't look like it's got an x squared term, but if I multiply that through, that'd be 3x, and this would be 5x squared. So that would be a 2-term quadratic that's already been factorized. This one here does not have an x squared term, it has an x cubed term. That's a cubic, not a quadratic. And this last one down here is a quadratic. So if you had any doubts there, that should have cleared it up for you. This one is not a quadratic. Okay, last question here. Factorizing these, filling in the blanks. I hope nobody left any extra spaces or punctuations. We're just putting in the x plus or minus or the number. Okay, so here, looking at this first quadratic, two-term quadratic, it's a difference of 2 squares. It's a dots. I see that the first bracket is only filled in for me. X times x would make the x squared. How many make that negative 16? I've got positive 4 here. Positive 4 times negative 4 will make the negative 16. And positive 4 plus negative 4 is why there's no. This next one down here, again, there's a hint. It's just one space in front of a set of brackets. So there's a common factor here. I don't need to set up 2 sets of brackets, x in both. Look at the common factor. I can divide both of these terms by x, but more than just x, I can divide them also by 5. So 5x out front. And inside the bracket, 5x times what would make 5x squared? 5x times x. And 5x times what would make negative 35x? 5 times 7 makes 35, so it's negative 7. X minus 7. Okay, next one. This is a quadratic, a 3-term quadratic, and it looks like it's already done for you. I've given you the x's in both squares will make your x squared. And you've got your numbers as well. 5 times 4 would make positive 20, and 5 plus 4, does that make negative 9? No, 5 plus 4 doesn't make negative 9. I need to think about my signs here. If I make this negative, could that still be positive 20? It could if they're both negative. Negative 5 times negative 4 makes positive 20, and negative 5 plus negative 4 makes negative 9. Same trick down here, but look carefully at the signs. I've got the numbers there for you, but how can I make that multiply to make negative 6? It could be negative 6 plus positive 1, or it could be positive 6 times negative 1. I need them to add to make negative 5 though, so that should tell me that the bigger of these two numbers should be negative. So negative 6 plus 1, that would still be a negative 5 answer. If I had it the other way around, positive 6 minus 1, that would give me a positive answer. I want a negative answer in the middle.